rules. I think as x goes to 0 from the right-hand side, what's this thing doing? Goes to infinity. What is this thing doing?
Going to
Goes to 0. And so I've got an infinity times 0 situation. Shoot, that's another indeterminate form. So I guess I'll rewrite that as a limit. As x goes to 0 from the right-hand side of the ratio of one of these beasts times the reciprocal of the other. Are you happy? Are you happy?
No,
What do you know? Why not?
because it hasn't been answered.
You guys, don't you agree? It's just kind of difficult not to differentiate the denominator. It's a lot of work. So I just think life would be so much easier. Instead of looking at the first times the reciprocal of the second, excuse me, I misspoke. Instead of the first divided by the reciprocal of the second, maybe my life would be a little easier. Looking at the ratio of the second as is. Oh shoot, that's easy to differentiate. To the reciprocal of the first. Let's see where I'm at. As x goes to 0 from the right-hand side, what does this thing go to?
0.
0. But as x goes to 0 from the right-hand side, what does this go to?
Infinity.
I can hear 0. 0 as well. It's a 0 to 0 situation. Oh, that just screams out at me. I can apply L'Hopital's rule. And applying L'Hopital's rule, I got the limit. As x goes to 0 from the right-hand side, help me with this, you guys. The quotient rule says I've got what's downstairs times the derivative upstairs, which is...
Why are we doing the
Good,
quotient rule?
I agree. But again, you guys, it's a common mistake I see. I'm applying L'Hopital's rule. You look at it and say, oh, I got a ratio, but I'm not really differentiating the whole ratio using the quotient rule, which I would use the quotient rule for a differentiated ratio. On the contrary, I think L'Hopital's rule says the limit of this beast is equal to the limit of the ratio of the derivative upstairs to the derivative downstairs, secant square root of x. Is that okay? Of course, if x goes to 0, oh, I'm tired of this, you guys. Let's do it one more time. Applying L'Hopital's rule. This gives a limit as x approaches 0 from the right-hand side. How do you differentiate this thing? It's past 7 o'clock. You're awake. How do you differentiate this thing?
Can't you just do it right there? Because
No, do it my way. What's the derivative of this thing?
was it derivative? Well, but
Well, what?
if you
Why
have
say
secant, well, if you have secant of x and it's going to 0, isn't that just 1?
So what's your point?
So you've solved it. It's just like 1.
What I want to hear you say is, this is not a candidate.
It's
for
not a
L'Hopital's
candidate for
rule.
L'Hopital's rule
I
at
do not get
all.
a 0 to 0 situation. I do not get an infinity situation. Don't just dive in and keep applying L'Hopital's rule because it seems convenient. Not that it is here. I think at this stage of the game, when I try to evaluate this limit when x goes 0, my numerator is immediately a non-zero, non-infinity value. It's just this. Over downstairs, that's the reciprocal cosine of x. But the cosine of 0 is just 1. So 1 over 1 squared is just simply a
1.
And I think that evaluates to 1. No, I'm serious though. Do you see my point, you guys? Don't just keep repeatedly applying L'Hopital's rule. It's got to be a candidate for applying L'Hopital's rule. You've got to have a 0, 0 or infinity over infinity situation.
Or 0 over infinity.
You know, 0 over infinity is not a good candidate because I think if you got the ratio of f of x and g of x, as f of x goes to 0, g of x goes to infinity, I think that limit for free is going to be 0. I think for free.
So Mike was saying that 0 over infinity is always going to be bad. You don't ever want to try and tackle that.
Why not?
That it's not going to work.
Why not?
I don't know.
I-
He told me that was the only, because when he was showing me L'Hopital in the math center, he told me that the 0 over infinity situation, you just don't even tackle that. It's not going to work with L'Hopital.
Well, true. L'Hopital's rule only applies 0 to 0, infinity to infinity.
Okay.
Brad, my question is this. It's different.
Yeah.
If you take the limit of f of x over g of x,
Yeah.
where f of x goes to 0, g of x goes to infinity,
Yeah.
say g of x increase that bound, then what can you say about the whole limit? It's for free.
It all goes to 0?
Perfect.
Okay.
Because if the numerator goes to 0 and the denominator increase that bound, I think that ratio has to go to 0.
Yeah.
Good. So yes, it's not a candidate for L'Hopital's rule, but at the same time, why worry about it? You know what the answer is.
What about infinity over 0?
Yeah.
Oh, that's just as nice. Because I think of f of x over g of x, where f of x increases up bound, g of x goes to 0, I think that ratio necessarily
That just goes to infinity, right?
increases
Yeah.
without bound.
Right.
I agree. So those are for free, those are not my indeterminate forms, meaning I know what they do, they're not indeterminate.
All right.
I'm sorry, Dave, that's okay. Oh, you guys! Spent a lot of time in the homework. Honestly, did that help?
Yeah.
If it did, let's do this.